Welcome to lecture 5 of module 2, second part, mutually induced EMF. We have already discussed what is statically induced EMF and self-induced EMF. What is statically induced EMF? In statically induced EMF, conductor is stationary and magnetic field is produced or changed by changing the current. Conductor remains stationary and flux linking with it is changed by changing the current through the circuit. By changing the supply, you are changing the flux linkage. Here magnet is stationary and conductor is stationary. We have studied two types, self-induced and mutually induced EMF. We have already discussed what is self-induced EMF. Next, in this video we can see what is mutually induced EMF. One of the example for mutually induced EMF is electrical transformer. Because you are applying current in one side, primary side, there will be a flux linkage and an EMF is developed in secondary side. This EMF is developed in the secondary coil due to the phenomena or principle known as mutually induced EMF. Suppose consider two coils. These are the two coils. First coil having N1 turns, second coil having N2 turns. You are applying current through the first coil. The EMF induced in the coil due to change in flux linkage when a change in current flowing through the coil is self-induced EMF. So if you are passing current through the first coil, what will be the EMF induced? EMF induced across this coil is known as, there will be a flux linkage in this coil. As a result, an EMF induced, that EMF is known as self-induced EMF. So, EMF induced in the first coil due to current in the first coil is known as self-induced EMF. And in the second coil also there will be a flux linkage due to this current I. As a result, an EMF is induced in this coil also. And that EMF is known as mutually induced EMF. When the second coil is brought near a coil producing changing flux, EMF will be induced in the second coil due to change in the current in first coil. So the EMF is induced in this coil due to current in the first coil is known as mutually induced EMF. We can write E1. This is self-induced EMF. N1 is number of turns in first coil into flux linkage d phi by dt. And what is E2? That is mutually induced EMF. First one is self-induced EMF. Second one is mutually induced EMF, that is minus N2 into d phi by dt. Number of turns in secondary coil into the flux linkage in the secondary coil. So, mutual induction can be defined as the property of coil to produce the EMF in another coil placed nearer to them when the current flowing through the first coil changes. So, EMF induced in the second coil when it is placed nearer to first coil, and if you are changing the current in first coil, an EMF will be induced in the second coil. That is known as mutually induced EMF. And this is the note which I prepared, mutually induced EMF. And the definition is EMF induced in the coil due to change of flux produced by another neighboring coil linked to it. It is called mutually induced EMF. Take this example. Consider a coil PS. This is coil P having N1 number of turns. This is coil S having N2 number of turns. And coil S is placed near to the coil P. This coil S is placed nearer to the coil P. Okay. When switch is closed, you close the switch. In the first circuit there is a battery, rheostat and switch arrangement. In the second circuit there is no battery, there is no current supply, only a galvanometer to show the deflection. When switch is closed in the circuit, current I1 flow through the coil P. If you close the switch, current will be flowing in this coil P and produce a flux phi1. Okay, so when there is change in current, a flux will be linked with P. Sum of the flux, say phi21. So phi1 be the flux linked with the coil P and phi21 flux linked with the coil S. Phi21 means flux linking with the second coil due to current in first coil. That is why it is denoted as phi21. So if you are passing current through first coil, there will be flux linkage. that is phi1 is linking with P coil and a portion of flux phi1 linked with S. That means phi21. Phi21 means flux linked with the second coil due to current in first coil. That is why it is noted as 21. 2 is flux linking with the second coil. 1 means due to current in first coil. So we can say that this phi21 can be written as, we can write this phi21 as, phi21 is proportional to which value? Phi21 equal to K into phi1. Phi21 equal to K times phi1. Okay. This is the relation between phi21 and phi1. Phi21 equal to K into phi1. This is suffix phi. Phi21 flux linked with the second coil due to current in flux first coil equal to K. K is the proportionality constant. This is also known as coefficient of coupling, which we will discuss later. K, that is a constant into phi1, flux linked with the coil P. Okay. If current flowing through the P is changed by changing the value of resistance. Next you vary this value of resistance. So what happens? There will be change in current. When there is change in current, there is a change in flux linkage. So phi1 is changing. As a result, phi21 is also changing if you are changing the current in first coil. And when there is rate of change of flux linkage, what happened to the EMF? There will be EMF induced in first coil as well as second coil. And the EMF induced in first coil is known as self-induced EMF. And EMF induced in this coil S, second coil, due to current in first coil, that is known as mutually induced EMF. See in this figure, there is a flux linkage with coil S due to current in coil 1. As a result, an EMF induced in the circuit, galvanometer shows the deflection. This is known as mutually induced EMF. A galvanometer is connected to the coil for measuring the induced EMF. Next we know that EMF induced in the secondary coil. This is the secondary coil. What is the EMF induced in secondary coil? This is proportional to current in the first coil. See it. EMF induced in the secondary coil is proportional to current in the first coil. So you can write EMF EMF induced in the secondary coil proportional to dI1 by dt, current in the first coil. And this proportionality is replaced by a constant known as M. EM2 equal to M into dI1 by dt. M is called constant of proportionality. Another name is mutual inductance. It is denoted as capital M. EMF induced in the second coil. Remember, this is the EMF induced in the first coil is known as self-induced EMF. EMF induced in the second coil due to current in first coil is known as mutually induced EMF. Next we can see what is this M. So consider the setup. Consider two coils which are placed close to each other. So coil 1 having N1 turns, coil 2 having N2 turns. If an electric current I1 is sent through coil 1, so you are passing a current 1 to the coil 1. Let phi1 be the magnetic flux linking with the coil 1. So when there is a change in current, a flux phi1 will be linking with the first coil. Let phi21 magnetic flux link with the coil 2 due to current in coil 1. So due to this flux phi1 or due to current I1, there will be a flux linkage in secondary coil also. Let it be phi21. The suffix is very important. 2 represent second coil, 1 represent current in first coil. So phi21 is flux linkage in second coil due to current in first coil. So if there are n number of turns or n2 number of turns, what will be the total flux linkage? N2 into phi21, which is proportional to which parameter? Current I1 in the circuit. If you are changing the I1, phi21 also change. Okay. So we can write this equation as N2 phi21 is the total flux linkage in the secondary coil, that is proportional to current I1. So this proportionality is replaced by a constant known as M21. What is M21? Mutual inductance in secondary coil due to current in first coil, M21. So N2521 equal to, this proportionality is replaced by M21 into I1. From this M21 equal to N2521 by I1. This is the equation for mutually induced mutual inductance. Okay. M21 equal to N2521 by I1. N2 is, this is mutual inductance M21. 521 flux linking with the second coil due to current in first coil. And in which coil flux is linking? In the second coil, that is why N2. And which current is responsible? Current in the first coil is responsible, so I1. So M21 is N2521 by I1. This constant of proportionality M21 is the mutual inductance of coil 2 with respect to coil 1, and it is also called coefficient of mutual induction. And can you define this coefficient of mutual inductance? Suppose you pass a 1 ampere current. So what is I1? I1 equal to 1 ampere. So I1 is 1 ampere. What is M21? M21 equal to N2 into 521. So therefore mutual inductance M21 is defined as flux linkage of coil 2. This is N2. Flux linkage of coil 2 when current of 1 ampere flow through coil 1. That is known as mutual. That is the definition of mutual inductance. If you pass 1 ampere current in first coil, then flux linkage in the second coil due when 1 ampere current flow through the first coil is known as coefficient of mutual inductance. Next, consider the case. If you are considering current in the second coil. See, in this figure we are passing current in the first coil. When you pass the current in first coil, you will be getting mutual inductance M21. Mutual inductance in the second coil. Next, we are passing current in the second coil. So, if an electric current I through, you are passing I2 through the second coil. Okay, so there will be a flux linkage in the first coil, that is known as 512. 512 is the flux linkage in first coil due to current in second coil, and an EMF induced in the first coil. So can you write the mutual inductance expression? M12. Yes, mutual inductance in first coil due to current in second coil equal to, which is the number of turn? N1. Flux linkage 512. Flux linked with the first coil due to current in second coil, divided by, which is the current responsible for this EMF? I2. Okay, so M12 equal to N1 512 by I2. So you got two equations for M21 and M12. M21 is N2 521 by I1 and M12 is N1 512 by I2. Next, see the EMF induced in the first coil. We can see what is the EMF induced in the first. We consider the first figure. You are passing current in the first coil, so an EMF is induced in the second coil. Take that figure. So what is EMF induced in the second coil? As per Faraday's law, N into d phi by dt, that is d by dt of N2 521. Number of turns in secondary coil into flux linkage of second coil due to current in first coil. We know that N2 521 is same as, what is N2 521 is equal to M21 into I1. So substitute M21 I1 here. M21 into I1. So what is EMF induced? Minus, we know that EMF induced in the secondary coil is minus M21 into dI1 by dt. E2 equal to minus M21 into dI1 by dt. So what is M21? E2 by dI1 by dt. Similarly, if you write M12, this is EMF induced in the first coil by dI2 by dt. Current is I2. And this coefficient of mutual inductance for the same circuit is having same value, that is M21 equal to M12 equal to M. If you are passing current in first coil or if you are passing current in second coil, whatever it may be, the mutual inductance between these coil value will be same. M12 and M21 equal to M. And the value of mutual inductance depend upon following factors: number of turns in the secondary or neighboring coil, then area of the coil, and closeness, how much it is in closeness. These are the three factors which depend.